So this next video is going to deal with the idea of testing a categorical syllogism for validity, and by way of using Venn diagrams. So basically we're at the point here where we can start to put together all these different ideas into a coherent system that we can use to determine the validity of an argument. What we'll be dealing with in this video is chapter 5, section 5.2 in the book. So at this point, it's useful to remind ourselves why exactly we're doing all of this in the first place. And if you recall, formal logic or deductive logic is really just concerned with the idea of determining whether or not an argument is valid or invalid. So to recap a little what we've been doing, remember that when we evaluate arguments of any sort, and that includes deductive arguments, there are always two fundamental questions that must be addressed, and these are needed to understand whether or not we have adequately evaluated an argument's merits. The first of these is, do the premises logically support the conclusion that's drawn? And if you recall, this question is not concerned with whether or not the claims you've made are actually true. The second question, of course, then turns around the idea of truth claims. And so it asks, are the premises of the argument actually true or not? Now, if you remember, a sound argument is a deductive argument that is valid on one side and that has all of its premises as true. And if you recall these two different sides of the equation, the valid and the true premises part, these essentially deal with our different questions. The question of validity deals with the claim, do the premises logically support the conclusion? And then, of course, the second question, are the premises true, deals with the other half of this equation. Now, remember when we talk about validity, validity is always a hypothetical concern. That is, if we simply assume that the premises were all true, would we have coherent, concrete grounds to claim that the conclusion is also necessarily true? And that's all it really means to say that an argument is valid. So if you're still not comfortable with the idea of validity, and in particular its association or disassociation with truth claims, I would strongly encourage you to go back to Module 1 and recap this concept. Remember, a valid argument is not concerned with whether or not anything you have said at all is true. It just wants to know, do those premises logically necessitate that conclusion, completely independent of whether or not anything you've said is true? So our question really in this entire video is, how do we know if a categorical syllogism is in fact valid? It is also worth taking a step back in the class again, but this time to remind you of the formal nature of deduction. If you recall, a deductive argument's validity is grounded ultimately not on the content of the argument, that is not whatever it is you're actually talking about, but instead merely on the form that the argument takes. So if we look at this particular example, all Greeks are humans, all Athenians are Greeks, therefore all Athenians are humans. Notice first of all, we have a nice AAA1, which as we'll see is really the textbook classic example of a perfect syllogism. This is a valid form of argumentation. Now here's the important basic concept. An AAA1 is always valid, it's a valid form of argument, and that is wholly independent of the context of the argument itself. In other words, we don't care about Greeks, humans, and Athenians when we look at the validity of the argument. What we care about is how we've organized those basic terms. What matters is instead simply the structure of the argument. And in fact, we could replace the S, P, and M in the particular form of argument we have here with quite literally anything, and it would still be a valid argument precisely because it has the correct form. So the big question we have now is, how do we actually test a categorical syllogism for validity? And as we'll see, there are a couple different methods we can use, and we're going to start this one by appealing to Venn diagrams. So we talked about Venn diagrams in the last module, and if you recall, Venn diagrams are basically circles that are used to represent classes or categories of things. And if you have a single categorical proposition, you will therefore need two different circles, one to represent the subject and one to represent the predicate. And of course, what we want to do is overlap these two things so that we can show every possible relationship that could exist between the subject and predicate terms. Now, if you recall, given that we have four and only four different types of categorical propositions, that means for any individual categorical proposition, there are four and only four possible ways that we can diagram these using Venn diagrams. If we have a universal affirmative claim, that is an all claim, remember what we want to do is diagram or shade on the outside of the subject circle. A universal negative claim is essentially going to shade everything in the middle part because we're saying those things simply can't exist. When I say no S's or P's, I want to say the entire class or category of S is distinct from the entire class or category of P. And so I color everything in the middle to basically erase or get rid of anything that could be both an S and a P at the same time. Notice our particular affirmative claims, the sum S's are P's, is simply going to put an X in the middle between the two circles in order to show that there is at least one thing out there that is both an S and a P at the same time. Now, there might be all kinds of other stuff that is an S without being a P, and there might be all kinds of things that are P's without being an S, but all we assert when we say some are is there is at least one thing out there that is both. And of course, the final possibility here is the particular negative claim, the some S's are not P's kind of stuff. And what we do here is simply put an X on the outside of the S circle to show that there is at least one thing that is in fact an S, but that is not a P and has nothing to do with the entire class or category of P. Now, some things to remember about this. First of all, notice that you will never ever shade an entire circle. If you're going to do shading, you must shade one side or the other of the S circle, the subject circle, but you'll never shade the whole thing. This is how categorical propositions work. Notice too that any marking you do to a diagram or a Venn diagram with a categorical proposition must involve the subject category. That is, it's either on the outside of the S circle or the middle piece that is both an S and a P, but regardless, it has to involve the subject term. Now, notice when we start talking about categorical syllogisms, it turns out that we're going to have three different terms, which means we need three different circles to represent each and every possible term in the argument. And of course, what we want to do is simply overlap all of them. So my three different terms are essentially my minor term, my major term, and the middle term. We've talked about those in an earlier video, but notice each one needs its own Venn circle. And what we want to do is simply overlap all three of them so that every possible relationship that could exist between the minor term, the major term, and the middle term is now shown by the overlapping circles. Notice what this does when we overlap all three of these terms. I essentially now produce 7 different possible sections in the Venn diagram that will express different relationships between all three of these terms, S, P, and M, or a minor term, major term, and middle term. So if you look, for example, at the number 7, that part of the Venn diagram in total is in fact part of the M circle, but it's not in the S circle and it's not in the P circle. So whatever we're talking about that would fit there is in fact our middle term, but it's not the minor and it's not the major term. If we move up to, let's say, number 6 here is one that is both a P and it is an M, but notice that it has nothing to do with the S circle. If we go right to the middle with number 5, notice that the position 5 is a P and an S and an M all at the same time. If we move up a step to number 2, notice number 2 would tell us that it is an S and it is a P, but it doesn't fit anywhere into the M category or circle, and so on. We can keep going. But notice the point here is that by simply overlapping these 3 circles now, every conceivable relationship between the 3 different terms available to us, the minor term, the major term, and the middle term, are now diagrammed on the Venn diagrams. So what is the process, or how is it that we exactly use Venn diagrams to determine if a particular categorical syllogism is valid or invalid? So before we start making sense of how to use Venn diagrams, let me give you a quick piece of advice. When you start doing Venn diagrams, what you need is ritual. You want to do the same thing the same way every single time without exception. So get into a sort of pattern, fall into a sort of habit. And once you've habitualized the process of going through this, it becomes painfully simple by comparison. If, on the other hand, you find yourself just kind of throwing things out there willy-nilly, it gets very confusing very quickly. So again, let me reiterate this point. When you start using Venn diagrams to figure out if an argument is valid or invalid, try to do the exact same thing the same way every time. There is a method here, and you need to be very fastidious in being consistent and forming a routine. So the easiest way to make sense of how Venn diagrams work to test for validity is to just jump both feet in and start with an example. So let's take a look at this particular argument. Now notice the argument is already given to you, and it's already given in standard form. We have all m's are p's, all s's are m's, therefore all s's are p's. Now the first step here is to simply figure out what the mood and figure is. And if you've gotten comfortable with this, you should know that this is an AAA1. So the first step in all this is to go and identify your minor term and your major term. Notice that the minor term here is S and the major term is P. And what you want to do is put them on top in order into the Venn circles, so that the first circle you come across on the top is your minor term. That's going to be S in this case, and the major term will be the circle directly across from it on the top, and that will be the major term, P. So you want to set them up in order every time, subject to predicate or minor term to major term on top in order. And that leaves the bottom circle to be your middle term. And you always want to basically set it up in this way so that your minor term is on the top left, the major term is on the top right, and the middle term is on the bottom. If you set things up the same way every time, it will simplify your life dramatically, because in the end, you're going to go look in the same place every time to see if there's a problem or not. Now notice what this accomplishes for you. We can now identify on the three-circle Venn diagram the two circles that represent our minor premise, that is the S circle and the M circle, the two circles that represent our major premise, that is the M circle and the P circle together, and then of course the top two represent our conclusion. So the process for determining validity really amounts to just diagramming both of your premises onto the three-circle Venn, and then checking it over and against the conclusion. So let's start with our major premise to see how this is supposed to work. Notice the major premise says all m's are p's. And if we just look at that all by itself, and we try to plug it into a single categorical proposition's Venn circles, what we find is basically this. Notice that an all m's or p's is telling us that I could never ever have something that is an m that does not fit into the p circle, and so I want to shade in everything that is an m but not a p in the m circle. Now notice what we can do when we want to transfer this basic idea over to our three-circle Venn is go find the m circle, because I'm doing something in this case to the m circle. I'm shading everything that doesn't fit into the p. And notice there are basically four different parts. Number one is an M and an S, but not a P. Number two is an M and an S and a P. Number three is an M and a P, but not an S. And number four fits into the M circle, not the S circle, and not the P circle. So the basic idea here is I want to find, of those four pieces, the two pieces that don't fit anywhere into the P circle. And of course, that will be number one and number four. Those are both in the M circle, but they're not in the P circle. Number two and number three are both in the M circle and the P circle, and those aren't going to be what we're looking for. So essentially, we just want to shade those two pieces like we did with the original two-circle Venn diagram on the right side of the page. These two pieces of the M circle are indeed in the M circle, but they have nothing to do with the P circle. And so I want to shade that and make it go away. All I'm doing is basically picking up this two-circle Venn on the right side of the page, and I'm plugging it in where it goes on the left side of the page, completely ignoring the S circle at this point. So now we want to do the same thing with regards to the minor premise. The minor premise says that all S's are M's And so if we set up our two-circle Venn diagram here, what we want to do is shade everything on the outside of the S circle that does not fit into the M circle, because what I'm saying is all S's have to fit in the M circle, and so I erase everything that isn't there. Again, remember when I shade something, I'm saying it does not exist. So what I want to do basically is go look at the S circle. The S circle will have 4 parts, 1, 2, 3, and 4 in this case. And I want to find the 2 pieces of the S circle that have absolutely nothing to do whatsoever with the M circle. And notice if you look carefully, you'll find that number 1 and number 2, those parts of the S circle, do indeed fit into the S circle, but they have nothing to do with the M circle. Now, whether or not number 2 is in the P and number 1 is not in the P doesn't really matter. It is an S, but it's not an M, and so I need to shade all of that part. So when I'm finished, the 2 premises put together tell me that all of this stuff that you see shaded on the 3-circle Venn cannot possibly exist. Those, in other words, that is the logical implication of these 2 premises put together. So the final step in all of this is to simply see if the conclusion agrees. If the conclusion agrees with what we've done by way of the 2 premises to the 3-circle Venns, then it's going to be a valid argument. If it disagrees, then it's not valid. And the idea here is really simple. Remember that to say an argument is valid means that the premises do in fact logically necessitate the conclusion. So what I want to see is, do these 2 premises, when put together, guarantee that what I claim in the conclusion has to be true? And indeed, if it does, then it's valid. If it doesn't, then it's not. So let's jump right in. Notice our conclusion claims that all S's are P's. And what that means is on the outside of the S circle, I could never, ever have anything that is an S that doesn't exist in the P circle. Those things have to go away. And so all I want to do now is take what I know about the conclusion based on this 2-circle Venn and see if it matches the 3-circle Venn. So all I want to do is go look and see if that same basic relationship in terms of shading in the S circle has been repeated by the combination of the 2 premises. So go over and find the S circle and look for any piece in the S circle that is not in the P and see if it's shaded. Well, notice the 2 pieces that are here outlined in the bright red color are in fact shaded. The top one is shaded in gray by the minor premise, and the bottom one is shaded in orange by the major premise. But those 2 pieces are now gone, and so it essentially agrees with the fact that you can never ever have something that is an S that doesn't fit into the P. Now notice all the other stuff that you see, all the other shading, all the other parts of the circle are simply irrelevant. For it to be valid, those 2 pieces, in this case of the S circle, have to match. That's it. If they do match, if all of it's shaded, then it's valid. If not all of it's shaded, then it's not valid. So notice, because all of it's shaded, we know that this is a valid argument. So we can say that an AAA1 is valid, and it's valid in any conceivable context where you find it. It doesn't matter what our terms stand for, whatever S, P, and M stand for, AA1 is always valid. So let's take a look at an example that is not valid. Notice this particular argument says all M's are P's, no S's or M's, therefore no S's or P's. If we wanted to figure out the mood and figure, this is an AEE1. So notice what we want to do here is we take our 3-circle Venns and we overlap them with 2 circles on top. And then we assign our minor term, which is S, and our major term, which is P, to the top 2 circles in order, and then our middle term goes on the bottom. So the next step is to just start plugging in the 2 premises, and we'll start on the top with our major premise. The major premise says all M's are P's, and if we wanted to plug this into a 2-circle Venn diagram to just see what it tells us, what we find is the following. Notice that this claim is asserting that everything that is an M has to be the sort of thing that fits into the P circle. And so what we want to do with our shading is just erase everything that fits on the outside of the M circle to show that those things can't possibly exist. Now the next step is to simply go over to the three-circle VIN and plug in exactly where it goes. And what we find here is if you look at the M circle, there are 4 pieces to it. 2 of them, the 2 now shaded, do not fit into the P circle, and the other 2 of the M circle that are not shaded do in fact fit into the P circle. So all I've really done is picked up these 2 Venn circles on the left side of or the right side of the page, and I plugged them into the left side where they belong. So now we can go look at our minor premise. The minor premise says no S's are M's. If we're to diagram this, what we're saying is anything that is both an S and an M at the same time has to go. So what we want to do is shade everything between the S circle and the M circle. Now, of course, what we want to do is go over to the 3-circle VIN and find the S circle, since that's the term we're starting with. There'll be 4 pieces to it. 2 of them are going to sit outside of the M circle, and 2 of them fit inside the M circle. Those 2 pieces that are in the inside of the M circle need to be shaded to represent the minor premise. This premise has told us that regardless of whether or not it's a P or not a P, anything that is an S cannot possibly be an M, so anything that is both an S and an M needs to be shaded. Now notice what we now know. Everything you see shaded here are what these 2 premises working together logically necessitate. Those 3 chunks of the M circle cannot possibly exist, is what these 2 premises working together tell us. So the last step is to simply compare this to the conclusion. Is the conclusion asserting the same thing? That is, does it agree? Well, the conclusion says I could never, ever, ever have something that is both an S and a P at the same time. If we diagram this into a 2-circle Venn diagram, notice what I need to do is have everything in between the S circle and the P circle shaded. And so what we want to do now is simply go compare that to the 3-circle Venn. And of course, what we're talking about, the 2 pieces of the S circle that are connected to the P circle are the 2 now that are red and highlighted in red. And of course, if you pay close attention here, notice that only one of those 2 pieces is actually shaded. But of course, the conclusion just told us I could never ever have something that is both an S and a P. And these 2 premises working together do in fact leave open the possibility that something is an S and a P at the same time, so long as it's not an M. So what does this tell us? Well, that means that these 2 premises together do not logically necessitate the conclusion that's drawn. There is still the possibility that I could have something that is an S and a P, even if it's true that all M's are P's and no S's are M's, so long as it doesn't have to do with the M circle. So notice what we've done here is because the S and the P section here between the 2 circles, all of it has to be gone for it to be valid. And given that it didn't happen on the 3-circle VIN, this shows us it's an invalid argument. Now notice all we care about is that little piece. Do these 2 chunks match? Every other bit that's going on around there, any other part of shade, any X, or anything you see anywhere else is simply irrelevant. All you want to know is, do these 2 premises, when put together, tell you the same thing that the conclusion tells you, which is I could never ever have something that is both an S and a P at the same time. And in this case, clearly not. So of course this means that an AEE1 is an invalid form, and we just proved this using Venn diagrams. And that means that an AEE1 is invalid anytime you come across that form of an argument, and it doesn't matter what S, P, and M might possibly stand for. So to be perfectly honest, that's all there really is to using Venn diagrams to test for validity. So if the examples we just went through made sense to you, if you understood what you're marking, why you're marking it, and how you use those markings to determine validity, you're actually in a pretty good spot with this stuff. Now there's only one catch left that we have to address, and that deals with particular claims, because sometimes particular claims can present a sort of problem for us that needs to be sorted out. Notice in the first 2 examples, both of the premises you had to work with were universal claims. But in this particular case, I have a single universal premise as a major premise, and then I have a particular claim as a minor premise. And when you find yourself in such a situation, this is going to present a sort of problem. Now the argument itself says all m's are p's, some m's are s's, therefore some s's are p's. And the mood and figure here is simply AII3. The thing to pay attention to here is that whenever you find yourself in a situation where you have one universal premise, whether it's major or minor is irrelevant, and the other premise is going to be a particular premise, there is an important rule that you have to apply. And basically the rule says this: whenever you find yourself in such a situation, always start with the universal premise. Whether it's the major premise or minor premise is simply irrelevant. Just start with the universal, plug it in first, and then deal with the particular second. And let me give you an example of why this would matter, or what difference this makes, by starting with the premise that is a particular. So if we set this up on our Venn diagrams, notice it's going to look like this. I have my minor term S on the top left, my major term on the top right, and my middle term on the bottom. And let's just start with the second premise in this case, our particular claim, some m's or s's. Now notice what this is telling me is that there is at least one thing out there that I know is both an m and an s at the same time. And to show that with the two-circle Venn, what I do simply is stick an x in the middle between the two to talk about that one example that is both an m and an s. Now notice, if we go to our three-circle Venn and we want to plug in the x where it goes, it's going to find itself sitting in this gray dotted line here. But the problem we have at this point is, all we know is that it is an m and an s at the same time, this one thing. But we really are not in a position to say what kind of relationship it has to the third term, to the letter p in this case. So it might go in the very center, that is an s, p, and an m at the same time, or it might just be an ms and an m without being a p. And we're not really in a position to say one way or the other where it goes. Now, when you find yourself in a position like this, the basic rule is as follows. What you do is you put an X on the line between the two pieces where it might go. So notice what this is showing you is we now know that there is at least one thing that is both an M and an S at the same time, but because it's sitting on the line, I'm saying I don't know if it's a P or not a P. I really can't commit one way or the other. And for what it's worth, if you ever end up putting an X on the line, this is a bad thing. It cannot be a valid argument in any case. So this is actually something that is going to be problematic for you. Now, we can sometimes at least fix this problem of the ambiguity of where that particular term goes by simply starting with the universal. And we'll see in this particular instance, the universal is going to actually solve for us where that X term has to go. So if we take the universal premise, our major premise here, all m's are p's, what I'm saying essentially is I can never have anything that is an m without it fitting into the p category. And so I want to erase everything that's an m but not a p. And of course, if we go over to our three-circle Venn, the two pieces in the m circle that don't fit in the p need to be shaded, and that would be those two that we see there. Now, once we've diagrammed the universal, and now when we return to our particular claim, we're potentially in a better position to deal with the ambiguity of that X and its relationship to the third term. Because now once we start plugging in our particular, what we find is this. Again, what we need is an X that is both an M and an S at the same time. I need at least one thing that's an M and an S at the same time. And of course, that X would have to fit somewhere into the piece that's dotted with the gray line there. So notice what the universal has done for us. The universal has actually taken part of the section we're looking at, and it's told us that that can't exist. Because remember, if something is an M but not a P, then it can't possibly exist according to the major premise. And so whether it's an S or not is irrelevant to us, but we now know that something that's an S and an M but not a P can't exist, because if something's an M, it has to be a P. So this shaded part there that the arrow is pointing to can't exist. And what that means is we now know that the X has to go in the other section. So notice that shows us, because of the shading, that we can push the X over into that section clearly, And now we're not left with the ambiguity of not knowing where it goes. We know it has to be an S, a P, and an M at the same time, because these two premises working together would guarantee that that has to be the case. So now that we've pushed the X squarely into that middle piece, we can just test it against our conclusion. So let's take a look here. What we find is the conclusion tells us there's at least one thing that is both an S and a P at the same time. And so, of course, we want an X in that middle piece. And when we go look at the premises to see if it matches, we discover, in fact, that there is an X sitting there between the S and the P circle. Now, it happens to be an M as well, but that's simply irrelevant. The conclusion only tells us there is something that is an S and a P at the same time. And these two premises working together do in fact show us that there has to be something that is both an S and a P in that section. So again, don't look at anything else around the argument. All you want to do is compare these two pieces. Whatever shows up in your conclusion has to show up in the section between the S circle and the P circle, or the minor term and major term. And if they match, then it's valid. If they don't match, then it's invalid. So in this case, this is a nice valid argument. An AII3 is a valid categorical syllogism. So at this point in the rest of the video, all I really want to do is walk through a handful of examples. So I'm going to give you a categorical syllogism, and then we'll just step by step walk through the answer to see if it's valid or not. And hopefully you can follow along. It's not a bad idea when you see it to pause the video, work through the problem on your own, and then see if you got the correct answer. So let's take this example. All P's are M's, all S's are M's, therefore all S's are P's. Now notice this is an AAA2, and the 2 part of that is because your middle term is sitting on the outside of both premises as the predicate term. So if we set this up on our Venn diagrams, we want to set up our minor and major term on the top in order, the middle term on the bottom. And since they're both universal premises, we don't really care which one we start with. So we'll just start right at the top and start plugging in our terms. The first one says all P's are M's. And so if we shade that in a 2-circle Venn, what we want to do is get rid of anything that's a P that doesn't fit into the M circle. And so, of course, when we go over to our 3 Venn circles, what we want to do is find the P circle and look for the 2 pieces of the P circle that do not fit into the M circle. One of them is in the S circle, one is not, but the 2 pieces that are not connected to the M circle need to be shaded. So now that we've plugged in the major premise, the second step is to start with the minor premise. And the minor premise tells us all S's are M's. And of course, when we say all S's are M's, what we're doing is saying if something is an S, it must fit into the M circle. And so we want to shade everything that's an S but not an M to say that that doesn't exist. And once we walk over to our 3-circle Venn, again, just go find the S circle and find any piece in the S circle that does not fit into the M circle and color it in. So the 2 pieces at the top there are going to be what need to be shaded. Now notice the piece in the middle was shaded by the orange already and by the gray. It's taken care of twice. It doesn't really matter. So the last step is to simply check it against the conclusion. Now our conclusion says, as a result of putting these 2 premises together, all P's are M's and all S's are M's, those 2 things logically necessitate the claim that all S's have to be P's. So of course, what that means is I would have to see all of the S circle shaded that doesn't fit into the P, because every single S that exists must be in the P circle. And so if we go compare the proper section here, the 2 pieces of the S circle that don't fit into the P circle are the ones currently outlined in a bold red color. And of course, what do we see? Well, it turns out that one chunk of the S circle is not in fact shaded. And so what that tells us is essentially that this is an invalid argument. And again, why? Because it turns out it's not necessarily true that all S's are P's. Even if it turns out to be true, those 2 premises together do not guarantee me that essentially I could never ever have something that is an S that doesn't fit into the P circle. So the fact that in this little section here, the bottom piece is not shaded, that's enough to show us that this must be an invalid argument. And so an AAA2 is an invalid argument. And if you want to know, just as a quick point of reference, when you look at your AAA arguments, AAA1, AAA2, AAA3, and 4, the only one of those that is valid is an AAA1. Every other type of AAA is an invalid argument, and for different reasons. So let's just keep going with some examples. Here's one where all three claims are negative. That is, I have three universal negative claims, two premises that are negative, and a conclusion that is negative. So we have no M's or P's, no M's or S's, therefore no S's or P's. This is an EEE3, and it's 3 because the middle term is on the inside of the two premises, or in the position of the subject, not the predicate. So we want to go over and set up our three circle VINs. Again, take your conclusion and just put your terms in order on top, minor term, major term, and then your middle term on the bottom. And then just start plugging away. Now notice again, both of these are universal premises, so it doesn't matter which one we start with, you just need to plug them both in. So let's start at the top. We want to say no M's or P's. And of course what that means is we need to get rid of anything at all that is both an M and a P at the same time. So we color in the centerpiece to show that everything that's an M has to be outside of or different from the P's, and every P has to be different than the M, and anything that is both an M and a P at the same time has to go. Now if we go plug this in on a three circle VIN, it's fairly simple. What we want to do is go to the M circle and go look for the two pieces of the M circle that are inside the P circle and color them in. Now we can move on to the second premise, the minor premise. And the minor premise is basically saying the same thing. This is saying no M's or S's. And so we want to get rid of anything that is both an M and an S at the same time. And we walk over to our three circle VIN, go find the M circle, and then look for the two pieces of the M circle that fit inside the S circle. What you want to do is color them both in. Whether it's in the P or not in the P, both of them need to go because this minor premise tells us anything that is an M cannot be an S at the same time. Now, we've seen what the two premises together tell us. All the stuff shaded on the three circle VIN cannot exist according to those two premises. So now we just need to compare that over and against the conclusion. The conclusion here tells us that no S's or P's. And of course, what that means is our conclusion, the conclusion we want to draw from these two premises, is that anything that is an S and a P together has to go away. I can never have something that's both an S and a P at the same time. And so I want to shade all the middle piece just like I did with the two premises. And then I just need to go compare. So you go find in the S circle, in this case, the minor term, the two pieces of that circle that fit in the P circle, and those two premises working together should have eliminated all of that. Now, of course, what we see here is that the conclusion has not actually been proven by those two premises. What we know is that there is still the possibility, whether it's actually true or not, that there is something that is an S and a P at the same time. It just couldn't fit in the M circle. So the fact that there is part of this section that is not shaded is sufficient to tell you that it is not a valid argument. So this is an invalid argument, and EEE3 is invalid. And in fact, any triple E is going to be invalid, and we'll see why soon enough. So let's just keep going with examples. So here's one where everything is a particular. So notice the first premise, the major premise, says some M's are P. The minor premise says some S's are not M. And the conclusion drawn from this is some S's are not P. Now the mood and figure is simply IOO2. And if we set up our Venn diagrams in order, we want the S term, the minor term in the conclusion on the top left, the major term on the top right, and our middle term on the bottom. Again, set these things up in the same way every time, and then you're just looking in the same place for your answer. It will simplify things if you're consistent about the method you use. Now, the first thing to note about this example is that both of my premises are particular claims. Now, remember the rule we saw earlier dealing with particulars only applies when I have a universal with a particular. Whenever I have one premise that's universal and one that's a particular, always start with the universal. But in this case, they're both particulars, so it really doesn't matter which one we start with. Just jump in at the top and start plugging away. So we can begin with the major premise, which says some p's are m's. And if you think about what this is telling you, it's telling you there's at least one p that is also an m at the same time, and that's all we know. So of course, we want to put an x into the space between the p and the m circle. And when we go over to our Venn diagrams, notice that the two pieces of the p circle that fit into the m circle are the ones that are shown by the dotted orange line. Now, of course, at this point, we're left with the ambiguity problem. All we know is that there is something that is a p and an m together at the same time, but I'm not in a position to commit one way or another to whether or not this fits in the S circle or does not fit into the S circle. And whenever you find yourself in a situation where you cannot commit because of a universal, one way or the other, you always want to put the X on the line. And as I mentioned earlier, this is a bad sign. Things are going to go wrong here. Notice that our minor premise is also a particular, but in this case a negative. And we'll see we're going to bump into the same basic problem here with ambiguity. This premise says there's at least one S out there that does not fit into the M circle. And so, of course, what I want to do is throw an X on the outside of the S circle here so that it is not involving the M circle at all. Now, when we go to our three-circle Venn, notice the section that we're talking about. The entire dotted gray line over there is, in fact, the portion that we're talking about where there is at least one thing that is an S but not an M. And of course, if you stop and think about it, we're bumping into the same basic problem. I know that it is an S but not an M, but I really can't say one way or another whether it's a P or not a P. So again, what we have to do is put the X on the line between those two pieces. And again, if it's on the line, what I'm saying is I don't know. It might be a P, it might not be a P. The most I can say is it is an S, but it does not fit into the M circle. Now again, on the line is a bad thing. And I think, frankly, as just a method, it's pretty useful to sit there and kind of dot the lines to see what section you're looking at so you know exactly where that X has to go and you can sort out where the problem is. But notice what we end up with, these two premises together give us an X on the line in two different places. And so now we can compare the conclusion here. The conclusion says some S's are not P. And of course, that means there has to be at least one thing that is an S that does not fit into the P circle. And when we go compare it, what we're talking about is this section. The section highlighted in bright red there is the portion of the S circle that has nothing to do with the P circle. Now notice, there is an X sitting there kind of clambering into the section, but it's on the line. And remember, if it's on the line, we can't commit one way or the other. So the fact that this X here does not fit squarely into the section we're interested in is enough for us to say it's invalid. And the reason we can say it's invalid is because this does not give us a necessary conclusion. Deduction wants a necessary conclusion where there is no possibility for it to be wrong. The fact that there might be an X in there is not sufficient to give us a necessary conclusion. And so when you see those X's on the line, start thinking something's going to go wrong. It doesn't work for you. And of course, in this case, what we discover then is that this argument in I002 is an invalid argument. The gray X here in the three Venn circles is not committed enough to the proper section to actually count as a valid argument. So let's take a look at another example. So this argument says no P's or M's, some S's or M's, therefore all S's are P's. Now, if you take a moment to just think about this and what you would have to do to diagram this, even if you don't actually sit down and diagram it right away, it's pretty clear that this argument just isn't going to work, because the major premise is going to tell you you need to shade somewhere in the middle, and then the minor premises says you'll throw an X somewhere. But of course, conclusion will demand that those two things together will have an entire outside section of a circle shaded, and there's not a chance you're going to get that from those two premises. So just staring at this, it should be really obvious that this is an invalid argument. The form it gives us, or the mood and figure, is EIA2, and again it's 2 because my middle term is sitting on the outside of both of my premises as the predicate term. And if we set this up on the Venn diagrams, what we find here is that the S again has to go, the minor term is the top left, major term top right, and then on the bottom we want our middle term. So we are indeed in a situation where we have one universal premise and one particular premise, and so you always want to start with that universal. So the major premise tells us no p's or m's, and what that means, of course, is that anything that is both a p and an m at the same time has to go. We want to shade the entire middle section between p and m. So now we move over to our three circle Venn diagrams, go find the P circle in this case, the major term, and then go look for the two pieces of the P circle that do indeed fit into the M circle and color them in. Because again, we want to say if something is a P, it can't be an M at the same time, and so anything that is a P and an M has to go. Whether it's an S or not, doesn't matter, those two pieces have to go. Our minor premise tells us there's at least one S out there that is also an M. Of course, that means that I want to put something into the middle section here. An X there tells us that there is something that is both an S and an M at the same time, at least one of those things. So go over to the S circle and then look for the two pieces of the S circle that do fit into the M circle. And of course, what I'm talking about here is the dotted gray line and everything that it covers. Those two pieces of the S circle are also in the M circle. Now I need to put an X here, and remember that because the first premise, the major premise, has already eliminated one of those two from existing, that means we know that the X has to go all the way squarely into the piece that is not yet shaded. So the X has to fit into this section, and again, because the shading tells us nothing could ever be in that area. The universal, in at least some cases, will allow us to solve for the ambiguity of where that X term goes, that particular claim goes. And in this case, we now know that the X has to fit squarely over into this section. So if you stop and think about it then, our conclusion says all S's are P, and what we'd need to do then is shade everything on the outside of the S circle between the S and the P circle. And of course, what we're talking about is here. So all of that should be shaded. And in fact, what do I get instead? I simply get an X. So it should be pretty clear that this is not a valid argument. So notice instead of getting shading in the S section that we're looking at here, what we have is an X there. And if you stop and think about this one for a bit, rather interestingly, we can go back to the square of opposition to see that this is actually quite logically problematic. Because if you stop and look at the original argument here, no P's or M's, some S's or M's, if what we wanted in the conclusion was to put an X in this section, the conclusion would actually have to be some S's are not P, right? Which is exactly the opposite, and in fact, the contradiction of the conclusion that is drawn here. So if you think back to your square of opposition, an actual rational logical conclusion to draw from this would be some S's are not P's. And this conclusion, all S's are P's, is in fact, it's contradictory. Now, if you didn't quite follow that, it's not that important, but it's quite an interesting little problem, so it's worth thinking about for a moment or two. In any event, what we know is that this is clearly an invalid argument, and EIA2 is always going to be an invalid argument, regardless of where you find one. So what we've covered so far in this video should be enough to get you through the core concepts of a Venn diagram and how to use them to test for validity. At this point, frankly, what you need to do is just practice a bunch. The more practice, the better. So just do example after example after example until this becomes second nature to you. And in fact, this is really just how logic works. The more practice you have, the better you get at it. Once you understand the system, and you've done it enough that you can just do it by rote memory, this stuff is actually fairly straightforward and simple. but it takes a while to get there, so I'd strongly encourage you to just practice using these things over and over again until you're comfortable with it. Now, if you noted, all of the examples that we've seen so far in this video have been given to you already put together in standard form. So we have arguments where everything is already laid out in standard form with the major premise on top, minor premise in the middle, conclusion on the bottom, and we've gotten rid of any actual content and put in our letters as placeholders. So the next step here is to try to put all this stuff together by looking at arguments that show up in actual ordinary language. Because what we have to do is take an argument that's given to us in ordinary language and then convert it into the standard form. Once we have it in standard form, then we can just run through the process of Venn diagrams to determine if it's valid or invalid. So let's start looking at examples. Let's take the following example, a rather simple argument. It says, some scientists are philosophers because some philosophers are mathematicians, and all scientists are mathematicians. Notice that the term because suggests that what follows that is going to be the set of premises that we have. And of course, the conclusion then is the thing that begins this whole argument. Some scientists are philosophers. And if you can start with the conclusion, it's a great place to start. The reason for this is it allows you to identify clearly what your minor and major terms are, and then you can use that as a reason to assign the major premise and the minor premise where they go accordingly. So our conclusion, basically devoid of content, would be simply some S's or P's. And then we want to plug in the rest of these, the two premises. We get some P's or M's, because some philosophers are mathematicians, and all S's or M's, all scientists are mathematicians. So the argument in its standard form, with the major premise on top, minor premise second, and the conclusion on the bottom, is some P's or M's, all S's or M's, therefore some S's or P's. And the mood and figure of this is an IAI2. When we set out to test the argument for validity, the first step is to set up your Venn circles in order on top, just like always. So our minor term goes on the top left. This is scientists. Our major term, philosophers, would be on the top right. And then our middle term, mathematicians, goes on the bottom. Again, try to set these up the same way every time. If you do, you'll be looking in the same place for evidence of validity over and over again. It becomes habit, and that's what you're looking for. Notice that in this case, we find ourselves facing that basic problem where our rule about particulars applies. We have one premise that's a universal and one premise that's a particular. And so we need to start with the universal. It's the minor premise in this case, but it doesn't really matter. Just start with the universal whenever you find yourself with one universal and one particular. Now this premise says all S's are M's. And so what we want to do is eliminate anything that's an S that does not fit into the M circle. So I want to shade the entire outside portion of the S circle between the S and the M. And of course, what we're talking about here, the two pieces of the S circle that do not fit into the M circle are at the top in the left-hand corner. So those two need to be shaded to represent the minor premise. Now that we have the universal plugged in there, we can turn to our particular. The particular claim, the major premise, says some P's are M. And of course, what that means is there is at least one thing out there that is both a P and an M at the same time. Now, if we want to plug our X in, the X that goes in the middle between those two things, go find your P circle and look for the two pieces of the P circle that do indeed fit into the M circle. And if you note, this orange dotted line sitting on the three circle Venns is exactly the piece where we need an X. But of course, notice, all we know is that it is a P and an M at the same time, but I'm not in a position to say whether it's an S or not an S. It could go in the middle, and it could go on the outside. We just don't know. In this case, the shading didn't help. So it doesn't always delineate for us where that X term should go. And so what we have to do is simply put the X on the line between the two pieces. Now again, as I've mentioned more than once, on the line is a bad thing. It can't commit one way or the other. It's not going to give us a necessary conclusion. So the next step here is to just compare it to our conclusion. the conclusion says there is at least one thing that is an S and a P at the same time. That means we need an X in between the S and the P circle. And if we go look at the section we're talking about, this highlighted in red here, these are the two pieces of the S circle that fit into the P circle. And all we want to see is that there is indeed an X squarely committed to that section. Whether there's shading in there, whether there's an X on the line, all these other things don't really matter. Just go look at that little piece all by itself and see, do you get an X? Now notice there's an X sitting on the line, but on the line is not enough to say we have a necessary conclusion, which means in turn that this is an invalid argument. So notice what we've done here with this example is we've taken an argument that's been given to us in ordinary language. We set it up into standard form, robbing it of any of the actual content and offering substitutions or letters as substitutions or placeholders for the terms. And then we ran it through a Venn diagram to determine if it's valid or not. And in this case, it was invalid. So let's add a layer of complexity to this and look at something more challenging. So in the example we just looked at, the premises and the conclusion stated in ordinary language were pretty much given to you in standard form. Some are, all are, that kind of thing. So what about when we need to translate? Because we rarely speak or write in standard form categorical propositions. So what about an argument where everything in there is not given to you in clear forms? So here's a great example of a categorical syllogism that is not given to you in standard form, and the various propositions in the argument are going to need a bit of translation for you to convert it into a standard form syllogism. I would also suggest that this is a really nice example of the kind of stuff you'll be doing on the test. What I will do is give you stuff like this one, and what you'll have to do is convert it into a standard form syllogism and then run it through Venn diagrams to determine if it's valid or invalid. And as we'll see, there's one step later that's coming next where you have to determine if it commits a fallacy or not. But take this example from Aquinas. He says, eternity is simultaneously whole, but time has a before and after, and therefore time and eternity are not the same thing. Our job here is to take this argument and convert it into a standard form syllogism devoid of actual content, where letters are simply acting as placeholders for actual terms. And of course, a good starting point is going to be, if you can, to find your conclusion. The conclusion, very nicely identified for you by the therefore, says time and eternity are not the same thing. Now, this is not given to you in standard form, but if you think about it, what it's saying is time and eternity are not the same thing. It's basically saying time is not eternity, or to put it into correct standard form, no things identical to time are things identical to eternity. And of the two premises that are left to us, the next one's actually the most obvious. Notice the second premise says time has a before and after, and that's pretty vague and ambiguous, whereas the first premise says eternity is simultaneously whole. We already have a pretty clear structure of a categorical relation between eternity on one side and things that are simultaneously whole on the other. So at this point, we just need to translate. Notice too that eternity was the major term in our argument. So if you go to your conclusion, our minor term is now time, eternity is a major term, and that makes this statement the major premise. And of course, to say eternity is simultaneously whole, properly translated would be something like all things identical to eternity are things that are simultaneously whole. And then of course we have the second premise, and this one's more ambiguous, but notice that at some point what we have to do is take the two terms left over and put them together. Our minor term is time, and now we know that our middle term is things that are simultaneously whole. And so if we just stick with those definitions or translations, to say time has a before and after is essentially telling you time is not simultaneously whole. And so if we want to translate, what we end up with is something like no things identical to time are things that are simultaneously whole. Now, we've worked through the hard process, frankly. This is, I think, the challenging part, is to take arguments given to you in ordinary language and then get them into standard form. When you're finished, you should have, notice, a clear argument where the major premise is on top, the minor premise is in the middle, and your conclusion is on bottom. And then what we can do is just check it for validity by running it through our Venn diagrams. So this form is simply an AEE2. And again, 2 because the middle term is sitting on the outside as the predicate of each of the premises. And then we just want to set it up appropriately where our minor term is on the top left circle, our major term is on the top right circle, and then our middle term goes on the bottom. So time and eternity is our conclusion. It goes on top. The middle term, things that are simultaneously whole, goes on the bottom. And of course, since they're both universals, we can just start plugging away in order. We'll start with all things identical to eternity are things that are simultaneously whole. All E's are W's. And of course, what we're saying is anything that is eternity must fit into the category of things that are simultaneously whole. And so we want to erase everything that is eternal but not simultaneously whole. And to plug this in on the 3-circle Venn diagram, what we do is simply go find the E circle and get rid of any piece that doesn't fit into the W. So I want to shade all the stuff that doesn't fit anywhere into the W circle, and it would be the 2 pieces you see now shaded. The next step is to diagram the minor premise. And the minor premise says no T's are W's. And of course, what that means is anything that is both a T and a W would have to go. So we want to shade everything between those 2 terms, T and W, make that go away. And then we just need to go plug it in on our 3-circle Venn. Now notice on the 3-circle Venn, go find the T circle, and then look for any piece of the T circle, there'll be 2 of them, that does not fit into the W circle, and just shade those in. So when we're finished, what we now see is all of the stuff now shaded by orange and gray here are what those 2 premises working together tell us cannot exist. So the last step is to just see if the conclusion agrees. And of course, the conclusion here says no T's or E's. And what that means is anything that is both a T and an E must go away. We have to shade everything between those 2 circles. And if we just go look at the T circle on the 3-circle Venn and find the 2 pieces that don't fit or that do fit into the E circle, all we want to see is that all of that stuff is shaded. And of course it is. Now the fact that there's stuff shaded elsewhere is not relevant. All of that stuff is gone. Those 2 things match, which means this is a valid argument. So this argument in AEE2 is valid, and it's not surprising. Aquinas is very good at this stuff. But what we get here is the whole process from beginning to end of dealing with a categorical syllogism. We started with an argument given in ordinary language. We translated each of the statements using the rules we saw to translate categorical propositions. We laid out the argument in standard form with the major premise on top, minor premise in the middle, and conclusion on the bottom. And then we simply ran through the argument to see if it was valid or not using Venn diagrams. And this is basically what you'll be doing on the test with, again, a little bit more added on if it's an invalid argument. So let's take one last example, and then we'll be done with the material for this section. This argument says, not every large chain store uses predatory market practices to drive out smaller competitors, and it is those chain stores that deserve to be boycotted. So it seems safe to say that not every big corporate store out there should be boycotted. Now again, this argument is not given to you in clear, obvious, standard form categorical propositions, so it's going to take a bit of translation. So the first step, a good useful starting point whenever you can, is to go look for your conclusion. And in this case, it's pretty clear what that is. There's a nice conclusion indicator. So, and the conclusion then is, it seems safe to say that not every big corporate store out there should be boycotted. Now when we say not every, what we mean basically is some are not. And so this basically is going to translate into some large chain stores, big corporate stores, however you want to translate this, are not stores to boycott or boycottable things or something like this. So some S's are not B's is pretty clearly our conclusion. We can jump to the first premise here. Notice it's the minor premise because the term large chain store, big corporate store, those are identical, has repeated itself. That's our minor term. And so we get, again, not every is going to translate into some are not. So we get some large chain stores are not predators or predatory market practice users or whatever. And then, of course, our conclusion, what we have to do is put together the remaining terms. So S has already been used twice in the minor premise and the conclusion, and now the major premise has to put together the major term, which is boycottables, and P, predators, as a middle term. And so we get, it is those chain stores. Well, which one are we talking about? The ones that are predators that should be boycotted, and B would be the next term. So the argument here is all P's are B's, some S's are not P's, and some S's are not B's. The mood in figure is A001. So the next step here is to set this up on our Venn diagrams. And again, we want to take our minor terms and our major terms in the conclusion and put them on the top two circles in order. So S stands for large stores, B stands for those stores we should boycott, and then we want to put the middle term on the bottom, which are predators or stores that use predatory market practices or the like. Now in this instance, it turns out that once again, we have two premises where one is a universal and the other is a particular. And so the basic rule about particulars is going to apply. And the rule says we should always start with that universal because potentially at least it can help us delineate where that particular claim might go. Now in this case, the universal is our major premise anyway, so we're just starting on the top, and so we can start there. So our major premise says all P's are B's, and so what we need to do basically is go find the P circle and eliminate anything that does not fit into the B circle. So we color the entire outside of that or shade it in. And going over to our three-circle Venn, find the P circle and look for the two pieces that do not fit into the B category, and then color those in. Now that we have our universal plugged into the three-circle Venn, we can take our particular claim, the minor premise, and see what it does. So this one says some S's are not P, and of course what this means is there is at least one thing out there that is not in the P circle that is an S. And so of course what we need is an X on the outside of the S circle that does not fit into the P circle, so as to show that here's one thing that's an S that is not involved with the P circle. So we can now move over to our three-circle Venn here, and we go find the S circle and look for the two pieces there that do not fit anywhere into the P circle. And so you can see that now by way of the gray dotted line here. And of course, notice what this does for us. We need an X somewhere in there, but we don't know if it fits in the B circle or does not fit in the B circle. So once again, the universal in this case did not help us sort out the problem of the particular. And so what we're going to have to do is put that on the line. So the X ends up sitting between the two, right, where it could be in the B circle or not in the B circle. All we know it is that it is an S, but it's not a P. We can't commit one way or the other to whether it fits in the B category or not. And of course, sitting on the line is a bad thing. So we now get to our conclusion. Our conclusion says there's at least one S out there that does not fit into the B category. And so, like with the premise, we need an X on the outside of the S circle. And now that we've solved for that, we just need to see, does the conclusion agree with the two premises when put together? So of course, the section we're looking at is all of this highlighted in red. And notice what we want to find there is just an X somewhere. Now there's some shading in there. We don't care about that. All we care about is, do we find an X inside clearly in that area? The X from the minor premise is on the line, and so it doesn't count. And again, the reason for this is we don't know technically with certainty which side of that line it would fit into. And remember that deduction wants absolute certainty. We want necessary conclusions. And so that non-committal nature of that minor premise is not going to be enough to make it a valid argument. So in the end, if we just go look at that piece, we find the x doesn't do what we want, and so we can say this is an invalid argument. So an A001 is an invalid form. And notice again what we've done is we've walked through the entire process here step by step. We started with ordinary language. We translated the individual categorical propositions into standard form. We laid out the argument in standard form as a syllogism with the major premise on top, minor premise in the middle, conclusion on the bottom. We figured out the mood and figure, and then we determined validity using Venn diagrams. And this is what you'll be doing pretty much for the test with one addition. So that's an end to this particular video. The video covers Venn diagrams and how we use them to determine validity with categorical syllogisms. Now this is, I think, at first a little difficult to get comfortable with, but once you understand the idea of what you're doing and you practice it a bunch, this becomes quite simple. So just practice, practice, practice as much as you can. And if you have questions about it, if you're not sure what exactly is happening there, I'd strongly suggest you read the book a few times carefully in this section, post questions on the discussion board, ask questions when we meet with our weekly meeting and through Zoom. And of course, you can always email me or we can set up a time to talk outside of that one meeting.